think I've got it. I crept up on it. I took another 0.02 aside cut out, and the bearing, I can just place it there. I can't push it in. It's just, I didn't push it in because I'll have to knock it out again, and I do want to Loctite this, and I do want to put a little chamfer on the front. So hang on, let's just pull him back out. There he is. So happy with that. I've run a spring cut through it. I'm happy with it. I know it's parallel. I know it's 22mm deep. That'll give me 2 of these bearings. Will go in there back to back, and I'll put a little 2mm spacer between them. You know, something like a 10.5 hole through the middle, 2mm thick, bit of brass maybe 12 diameter, something like that, just to keep the 2 races a bit further apart. And we'll have a go at assembling it. Just while I'm here, I don't know why I'm going in that direction when I want to be in reverse. I'm just going to put back, put a 45 on there. I want more of a leading chamfer just to start the bearing, so spin it round a bit more. There we go. Now then, on this outer face, I think what I'll do is leave a wall thickness of about 2mm, put a nice sort of 30-degree angle on the top of here, just so that it looks nice, really. So it's 12:30 and it's already 26.5 degrees in here. So I swung my compound over 30 degrees and just put a nice big chamfer on the front edge, and I'll leave about 2mm of face size on the front. I'll see how it looks basically. Let's see if I can give you a better view of this. Looks like that. I think we'll go another, I don't know, can't see it now, let's get that out of the way. Yeah, another 0.5mm. Quite nice finish that. Come on, up you come. Oh well. Come on, back off the edge, I'll get it then. It's getting mighty hot in here. A little bit more maybe. I think I may need to adjust my compound a little bit. So I felt a bit of wobble then. And I think that's going to be my finishing cut. Okay. We'll call that done. I've just noticed a slight design flaw. Now I would have liked a bigger shaft sticking out at the end of here than 5mm, but that's by the by. That's the bearing I could get that would go, you know, 16 in a 20, so to speak. I didn't want to use a 19mm bearing. I could have got a 19mm bearing, I believe, with a 8mm bore, or I think it was a 6. But it, you know, for what it was, it would have left me with a thin wall on the outside and what have you. But the design flaw is, if you look at these bearings, this is a steel caged bearing with a steel you know, rubbish guard on the outside. Seal, we'll call it, metal seal. The metal seal will be below the outside surface, but the outside surface, this face here, and the face of the inner race are in exactly the same plane. Now, the diameter of that inner race is, let's have a look, let's call it 8.5 mil, which is absolutely fine for this end because I've got the 16 mil running in for 5, and then I've got it bored out to 14.5 for a certain distance. So this inner race, as it's rotating, is actually going to be, as you can see looking up the end here, it's going to be in fresh air. When it comes to the other end, again, I just put my 14.5 mil drill up, and the diameter of this race here, the inner one, is just a smidgen over 15 mil as far as I can measure it. So what that means is that when I push the rear bearing in against the back face in here, let's just try and bring that into shot. When I push the rear bearing in against this back face, the inner race is going to be also on the back face and rotating against that back face, and it will rub. So what I need to do is to, what I'll probably do is just pop this back up in the lathe, put a 16 mil drill down the bore just for, you know, a couple of mil, much like the end of that 14.5, as you can see there. Just open that up to 16, and then I know then that the rear race, the inner of the rear race, is running in fresh air. So yeah, a little design flaw that while I was doing it, I just forgot to do it and didn't look at it while I was doing it. But looking at it and what have you, I'm not going to fit these bearings until final assembly because they are a press fit and I might need to bugger about with things. So anyway, yeah, just something to bear in mind, that the inner bearing is exactly the same plane as the outer. So if you're dropping a bearing into a housing, you need to make sure you've got clearance on the inner race where the back register of the hole comes. So I'll just put that right. Well, as soon as I got the boring bar here, I'll just use the boring bar. Let's have a look where we are. It's on the 14.5. Set a 0. That's on the 14.5. There's 0. Half mil out. Another half mil out. I'll go another half mil for that, why not? Just got plenty of clearance. Very nicely. So that's it, clearance on the inner race. So other than a flat along the top of here, so that when the grub screws, or the screws come down in the tool post, where, you know, if it leaves a mark or what have you, it'll be less likely to leave such a nasty mark with a flat on there. And if it does bruise the surface at all, with it being a good fit in the holder, I'll still be able to pull it out because it's a flat. So we're going to move on to making the spindle. Now, I've found this piece of stainless. It's 16 diameter, 140 long, and I'm thinking I want sort of 15 mil hanging out the front, and yeah, I'll sort of 20 mil hanging out the back, whatever. We'll use that as a starting point. With it being 16 diameter, and the OD of this inner race being 15, I can leave the full 16 sticking out the front, and it'll be a good shoulder to push back against for the spindle. So far so good. So let's see where I am. I've got my piece of stainless up in the lathe. I've got about 15-16 mil of the larger diameter there. And my plan is I'm just going to rough this down to start with. I've got about 123, 124 mil length here. I'm going to have a bearing journals up this end, which, if you can imagine, it will run inside there. And my bearing journals have to be 10 mil. Nominal 10 mil bore in the bearings. So I'm going to rough this down to 10.5 along its complete length. And then I'm going to look at turning this end before I do my journals, all that sort of stuff. And what I plan to do is replicate the end of this. And this, well, I haven't double checked it, but I'm pretty sure it's M8 by 1mm pitch. So I'll probably turn down the end of this down to M8, 1mm pitch. We'll see how I'm going to do that. I may end up having to screw cut it. I don't think I've got a die for that. Which will allow me not only to use the collars, the same little nut, and the same little little collets that we used in this, but I will have the opportunity of screwing other objects on the end of it that have got an M8 by 1 pitch on the inside, as it were, so I could screw those on as well and have sort of multiple different fittings, maybe a little pin chuck, something like that. So I'm trying to make it a bit more versatile, and as I say, this is like I think this is plan B now. Goodness knows what letter we're going to end up on. I'm taking about 0.2 at a time, and this stainless bar actually machines really nicely. Weirdly, I tried my general purpose tips and I wasn't getting much of a finish, so I've gone back to the aluminium grade tip. I'm not loading it up, I'm just running very light cuts, and I'm getting an absolutely superb finish. I do get a little bit of deflection in the middle, but if I run very light cuts and then run a spring cut, it comes back to true diameter all the way along. So I'm just going to run this down to a nominal 10.5mm now, and then I'm going to turn it round. As you can see, that's machining absolutely beautiful. I have got a little bit of my cutting compound on there. Just bit on my brush, just brush it every time, and that's what the smoke is. So I'll just run that cut to the end, and we'll have a measure. I've set a stop here, and that's the stop. As you can see, it does scratch through the centre there. If I run that cut again, it takes the spring out of it. So I'll bring you back when we're done. So I think that should be about it. 10.48, something like that. That's a quick 10.47, 10.48, that's fine. So there's plenty of meat left on there for when I come back and turn the journal. And what I will do is turn the 10mm diameter for the bearings, 10.01, something like that, over like 24mm, and then undercut the rest down to 9.5 all the way along, and then obviously turn the end down to the 5mm to fit the 5mm bearing in the back end. But what I want to do is do this front end now before I've got a series of different diameters on here. So I've got something nice and plain to grip on, and I'm going to turn the head end, which is where my grinding wheels are going to fit. So I'll just take a little scratch across the face. Just to verify that face. Set a 0 on my DRO. I'll set my stop at 11.8. Oh, that's alright. I'm going to go about 12mm. These are about 3 or 4mm of the major diameter. And now I need to turn this down to 8mm. .2 at a time. Don't want to go mad in it. I don't know how these tips are going to last with stainless. I'm looking for a diameter here of 8mm for the thread. We'll bring you back when we're somewhere near. We're down to 8.3mm now. So I'll just take 0.1. I've put a little undercut in the back end, off camera. So this should leave me about 8.1. I'll just do a double check. taking 0.05 aside, just creeping up on the finished size of 8mm. Let's have a look, where are we? I don't know if you can pick that up, just over 8.1mm. So, another 0.05. And that should be my finishing cut on there. And what I'll do is do a spring cut. Yeah, it's still scratching slightly. Hopefully that'll get rid of that 0.01 bit. I'm just doing this to a nominal size. So let's have a look at that. And there you are, 8mm, pretty much on the nose. So, it's going to need a hole up the end to take the collets. I'll try and have a measure of the existing one, see what size it is, and see what we can do to replicate that. I don't know whether you can pick that up or not, but I just measured one of the collets, and we're looking around 4.9, just over 4.9mm. I don't know whether you can quite see that. Get the light right. Anyway, take my word for it, it's 4.9mm. So what I'm going to do is draw or drill a 4.8 hole up the end to start with.